Okay, Matrix, let's look at another example in this lesson. We'll call it example 3. Okay, and again, I'm not going to use too many words, but I'm just going to go to the diagram, give you the information, and then let's have a look at some questions. Okay, in the figure, the tangent touches this circle, and the circle's equation is x squared minus 2x plus y squared plus 4y is equal to t. Okay, so that's the equation of the circle with a center at A. Alright, and then what we can do is the point where the tangent touches the circle is going to be -2 and -1. That's the point D there. O, of course, is the origin, A is the center of the circle, and the circle is going to be cutting the y-axis at the point B and C. Okay, so it cuts there and there. Alright, now what we want to do with this given information, the first question I want to discuss is determine, so let's determine the coordinates of A. So let's determine point, we'll call it point A, the center. Okay, point A, the center of the circle. Okay, now how do we get the center of the circle there? Well, we're going to have to complete the square on this equation. Okay, so let's rewrite that, and then we can easily determine the center there. So let's write it down. We've got x squared minus 2x plus y squared plus 4y is equal to t. So if we complete the square, remember, what are we going to do? We're going to go x squared minus 2x, and in fact what I'm going to do is I'm going to actually make it a little bit easier for you here. Let's to save a little bit of space. If you have a look at this thing, what is the, if you take those two guys, what is half the coefficient of x all squared, and what is half the coefficient of the y all squared? That's a half of -2 is -1 squared, which is 1. Half of 4 is 2. 2 squared is 4. Okay, so what we're going to do is we're going to add to the left and right these numbers here. So we've got x squared minus 2x, we're going to plonk in 1, and then we go y squared plus 4y, and we add 4 there. Then on the right side we're going to do exactly the same. So we add the 1 and 4. What we do to the left, we do to the right, and the t stays there. This is a perfect square, so we can factorize it as usual, and this is a perfect square trinomial, so we can factorize it, and this gives us t plus 5. Okay, and remember, this is r squared. Okay, what is the center A? The center A would be, okay, that's -1 becomes 1, +2 becomes -2, and that is your center of the circle, so we can write it in there. The center is x is 1, y is -2. Great, so there's the coordinates of the center. You'll notice I've done a lot of completing the square throughout these examples. Okay, the next question I want to discuss is express the radius. Express the radius in terms of t. Express the radius in terms of t. Now, what do we know? We know that r squared is t plus 5. That is, the radius squared is t plus 5. So the radius is then the square root of t plus 5. That is expressed in terms of t. Okay, alright, now the next question, number C, have a look at this. I want you to show that t is equal to 5. Show that t, the value of t is equal to 5. Okay, now how would we do that? Show that the value of t is equal to 5. Well, what we could actually do, if you think of what is the radius, if you think of this little radius here, if I draw it in here, yes, I'm going to draw in my radius, and there's my center. The radius and the tangent are perpendicular, but if you look at the length of AD, there's your radius there, the length of AD. Let's use the distance formula to work out the length of AD. We've got something for r, and maybe it'll work. Let's have a look here. So if I take my coordinates here, let's have a look. We've got A is going to be the center there, which is +1. Let's just do that again. +1 and negative 2. That's your center there. Then we've got the point D as negative 2, negative 1. Let's just double check that. If we go up to the diagram, D is negative 2, negative 1. A is 1, negative 2. Now let's work out the distance here. AD squared. How do we do that? Well, we could say 1 minus negative 2. If you go this way, 1 minus negative 2 squared. The x's, the difference between the x's, all squared, plus negative 2 minus negative 1 squared. That x minus that. And then this gives us AD squared is equal to, that's 3 squared, which is 9. Negative 2 plus 1 is negative 1 squared is 1. So then your AD squared is equal to 10. But what do we know? That is actually, if you think about it, this R is actually the length of AD. Think about it carefully. This AD is the length of the radius. So what we could then do is we could say, well, AD is the square root of t plus 5, but that's squared. Okay? And then what does that give us there? This gives us, if you square the root, it's t plus 5 is equal to 10, and therefore t would be 10 minus 5, which is 5. So we've got the t there being 5, okay, which is great. So that we can fill in the equation. If you go and have a look here, this t now becomes 5. So we can remove that there and plug in the value of t, and we've got a full equation there. Okay, now another nice question is, remember in the previous example we worked out the x-intercept of the circle. How about the y-intercepts b and c? How would we do that? Well, we've got our equation of the circle, so let's have a look at number D. Okay, now if we look at that, the coordinates there, what we could say is we've got the equation of the circle. Okay, there it is there. We've already got this, and we've established that that is equal to 5. Okay, that was what t was. Okay, now if we let x be equal to 0, we are going to get the y-intercepts of the graph. So if we let x be 0, that's going to be 0 squared minus 2 times 0 plus y squared plus 4y is equal to 5. So that's nice. The x's vanish, and we've got y squared plus 4y minus 5 is 0. And we can then factorize the trinomial. There we go. And we've got y is equal to negative 5, or y is equal to 1. So if you go and have a look at the coordinates there, let's go up to the circle. B here, the value of b here, this will be 0, negative 5 for b. And the y value at the top here would be 0 and 1. So there we've got it. The coordinates of b would be then 0, negative 5, and c would be 0, 1. Those are the y-intercepts. Remember, for x-intercepts, if you wanted these x-intercepts here, you would let the y be equal to 0, as we did in a previous example there. Okay, now number E, what would be, I want you to tell me, what is the length of BC? What is the length of BC? Now that sometimes comes up, the length of BC. Well, that piece here is 1, and that piece is 5. The length from 0 to negative 5, you displace downwards, but the length is 5, positive 5. So 5 plus 1 is 6. So BC is going to equal 6 units. So we can say here that BC is equal to 6 units. Okay. Very nice. And then what I want you to do in the next, or the last part of this question, I want you to determine the classical question is determine the equation of the tangent. Okay, determine the equation of the tangent to the circle at the point D. Determine the equation of the tangent of this tangent at point D. Well, how do we do it? Well, we get the gradient of the radius. Let's do that first, and then we can get the gradient of the tangent, and we've got a point on the tangent there. So, okay, so let's write down the coordinates of D, and that's going to be negative 2 and negative 1, and then we've got the center, which we've already worked out there, was 1, negative 2. Let's just go back and check the diagram quickly. There it is, 1, negative 2 for A, and D is negative 2. So we can get the gradient of the radius. So the gradient of AD, which is the radius, will be, okay, let's go -2 minus -1. So we'll go this way, that minus that, the y of A minus the y of D over the x of A minus the x of D. So what does this come to? -2 plus 1 is -1 over 3. So that is going to be the gradient of AD. What's the gradient of the tangent? Positive 3 over 1, which is 3. You swap those around and change the sign. 3 multiplied by -1/3 is -1. So the gradient of the tangent is then 3. So we've got, if you look at the point which is D, which is -2, -1, that's your x1 and your y1. There's a point there, and your gradient of your tangent is 3. So we're in a position to say y minus y1 is mx minus the x1 there. And we can easily get the equation of the tangent. Simply multiply out, and there we go. We've got it in no uncertain terms here. Y is equal to 3x plus 5, and that is your equation of the tangent there. What a pleasure this is. Okay, so these are questions that link all the grade 10, 11, and 12 analytical together there.